AASHTO T-27, sieve analysis of fine and coarse aggregates, covers the determination of the particle size distribution of fine and coarse aggregates by sieving. Terms used in this standard are defined in ASTM C125. In this method, a sample of dry aggregate of known mass is separated through a series of progressively smaller openings for determination of particle size distribution. The grading results are used to determine compliance of the particle size distribution with applicable specification requirements, and to provide necessary data controlling the production of various aggregate products and mixtures containing aggregates. For this procedure, you will need an oven capable of maintaining a uniform temperature of 230 plus or minus 9 degrees Fahrenheit, a balance readable to 0.1% of the sample mass or better and conforming to the requirements of AASHTO M231, a nest of sieves conforming to the requirements of AASHTO M92, and a means of providing agitation of the sieves in a manner that results in the separation of the aggregate particles conforming to the section of this standard regarding sufficiency of sieving. A mechanical sieve shaker is commonly employed and is recommended for certain sample sizes. Obtain the sample according to AASHTO T2 and reduce to testing size according to AASHTO T248. The mass of the field sample shall be the mass shown in T2 or 4 times the mass required by this standard, whichever is greater. For fine aggregate, the sample size must be at least 300 grams. The size of the test sample for both coarse aggregate and mixed coarse and fine aggregate shall conform to the table in section 7.4. If the amount of material finer than the number 200 sieve is to be determined by AASHTO T11 and T27, use one of the following procedures. For aggregates with a nominal maximum size of 1/2 inch or less, use the same sample for both T11 and T27. For aggregates with a nominal maximum size greater than 1/2 inch, use either the same sample for both T11 and T27 as previously stated, or use separate samples for AASHTO T11 and T27. First, we'll demonstrate the procedure on a sample of fine aggregate using 12-inch round sieves. If the sample has not been washed and dried according to T11, dry the sample to a constant mass at 110 plus or minus 5 degrees Celsius. That's 230 plus or minus 9 degrees Fahrenheit, and record the weight to the nearest 0.1% of the original dry sample mass. To determine the required accuracy of the balance, that is, to how many decimal places the scale must display, multiply the sample weight by 0.001. The resulting product will determine the largest interval that your scale must accurately display. For example, a 100-gram sample must be weighed on a scale accurate to 0.1 grams, while a 10,000-gram sample requires a scale accurate to only 10 grams. Select sieves that meet the requirements of the specification for which the material is to be tested. Additionally, include sieves as desired or necessary to provide other information, such as fineness modulus or to prevent blinding. Remember to carefully examine and clean all sieves before use. Nest the sieves in order of decreasing size from top to bottom. Place the sample in the nest of sieves, taking care that no material is lost. Cover the top sieve and agitate for a period of time that meets the requirement for adequacy of sieving. When the sieving procedure is complete, record the accumulative weight of the material retained on each sieve. Remember to check each sieve for blinding and make sure that all material is transferred to the weighing container. Use a rigid instrument to remove lodged particles from coarse sieves. On finer sieves, use a brush that will free the particles without causing damage to the mesh. To easily check for overloaded sieves, record the individual weight of the pan material before adding it to the accumulated weight of the sample. Coarse aggregate samples are frequently tested with rectangular sieves having a relatively large effective sieving area. As with any sieving operation, Make sure the sieves are clean and free of particles before use. Don't forget to secure the sieves tightly in the shaker. Place the sample in the shaker and agitate for a sufficient time period. Record the accumulated weights from each sieve. Make sure all particles are removed from the sieves without causing damage to the screens. When grading specifications require more sieves than the shaker's capacity allows, it is a common practice to transfer the pan material to a second nest of sieves with sufficient capacity. For this demonstration, we are testing aggregate for concrete, and the last sieve above the pan is a number 8. The specified gradation also includes the number 200, so the pan material will be transferred to a nest of round 12-inch sieves and sieved in the 12-inch shaker to complete the test requirements. Now, let's look at the procedures for calculating and reporting the test results.
In this section, we will cover the calculations required for T-27. Depending on the specification, sieve analysis calculations may include the total percentage of material passing each sieve, or the total percentage of material retained on each sieve, or the percentage of material retained between consecutive sieves. In some cases, such as a gradation for concrete sand, you will also be required to calculate an index of the fineness of the aggregate, which is referred to as the fineness modulus. Percentages are calculated from the original dry mass of the sample. It is a common practice to test samples by both T11 and T27 to get the most accurate determination of -200 material. In such cases, you will run T11 first and use the initial dry mass from that test as the basis for calculating all the percentages in T27. To calculate the percent retained on a sieve, divide the accumulated weight by the initial dry sample mass and multiply by 100. For example, if the accumulated weight on the half-inch sieve is 6,776 grams and the initial dry mass from T11 is 11,486 grams, the percent retained is 6,776 divided by 11,486 times 100, which equals 59%. To get the percentage passing the same sieve, simply subtract the percentage retained from 100. In this case, the percentage passing the half-inch sieve is 100 minus 59, which equals 41%. To get the percentage retained between two consecutive sieves, you will use the mass of the material retained on each individual sieve. When this data is required, it is a good practice for inexperienced technicians to actually record the weights from each sieve. This practice not only provides the necessary weights, but also allows the technician to easily check for sieve overload. Use the percentage retained formula. Only substitute the accumulated weight for the weight retained on a single sieve. Again, using the half-inch sieve from our example worksheet, 4,837 grams of material was caught between the 3/4 inch and the half-inch sieves. 4,837 divided by 11,486 times 100 equals 42.1%. For some materials, such as concrete sand, you may be required to calculate the fineness modulus. To calculate fineness modulus, add together the cumulative percentages retained on the following sieves. The number 100, 50, 30, 16, 8, 4, 3/8 inch, 3/4 inch, 1.5 inch, 3 inch, and 6 inch. Then divide the sum by 100. For our fine aggregate example, the largest sieve in the series to retain any material was the number 4. So we add together the percentages retained from the number 100 through the number 4 and divide the resulting sum by 100 to get a fineness modulus of 2.49. If you are required to calculate a fineness modulus, Make sure you include all the necessary mesh sizes in your nest of sieves. If the sample was tested by both T11 and T27, be sure to add any material passing the number 200 sieve in T27 to the wash loss from T11 to get the most accurate determination of -200 material. If the percentage passing the number 200 sieve is greater than 10%, report to the nearest whole number. If it is less than 10%, report to the nearest 0.1%. Report the fineness modulus to the nearest 0.01%.
For more details on the most recent specifications, consult the latest AASHTO publication, which may be ordered by calling 202-624-5800 or online at transportation.org.